So using the book's notation in their table, they have, for instance, x equals negative 1.05, the first value I chose. Then they have y. So y is obviously the function value when x is negative 1.05. And that's going to be, because our function is, the reciprocal function 1 on x is going to be 1 over negative 1.05. All right, so there's our function value. Q is these two put together, negative 1.05 and negative 1 over 1.05. Right? So Q in the picture is this point, right, that I'm placing on here to construct the secant line between P and Q. So I'm just going to label this as Q now. And Q is, in a sense, moving down the curve towards P, right? It's going to get closer and closer to P without ever becoming P, but we'll get closer and closer, okay? So you see already this is close to negative 1, right? In both cases, x and y are not quite negative 1, but as we increase the x values, right, to negative 1.001, this will get closer and closer to being negative 1 itself, and it will start to reveal what the slope of the curve is there. All right, msec, which is also in the table, msec is slope of the secant, right? Slope of the blue secant line that I have in my picture. Right. So what's happening is you construct Q, and the secant line between P and Q, P never moves, Q is moving. P and Q have a line between them, right? They share, and that is our secant, and the slope of the secant is what we're interested in, because it's going to get closer and closer to becoming the slope of the tangent line. Okay? So msec, m, usual notation for slope, and secant because it's a line connecting 2 points on a curve. That is what a secant is. All right, so now to do a calculation. So msec should be the points P and Q, right? The slope between those 2 points, slope of the line between those 2 points. So P was what? Negative 1 for the y value, negative 1 for the x value. They were the same. And now I take Q, right? I take its x value, I subtract it away, right? Usual slope formula, right? Subtract it away from the x value of P, and I subtract away the function value away from the function value of P. Negative 1 over 1.05. There. All this is y2 minus y1 over x2 minus x1. That's all it is, okay? For particular points, P, right? Negative 1, and Q. And Q is changing all the time, right? But our first location is negative 1.05, negative 1 over 1.05, and P was negative 1 comma negative 1. Y2 minus y1, x2 minus x1. There. So now we just do the calculation. Okay. All right, I'll just do it. So equals. I see a little assistance here. It looks like that if I were to rewrite this, maybe something like this, plus 1 over 1.05. And the bottom, I'll have negative 1 plus 1.05. Because the numbers are so similar here, I kind of noticed something, that if I multiply the negative 1 by 1.05 over 1.05, so the top has the same denominators, it looks something like this. Negative 1.05 plus 1 over 1.05 over negative 1 plus 1.05, negative 1 plus 1.05. Okay. Now you can do this with a calculator. For these types of problems, it's not a big deal because the computations can become too intense, but this one seems simple enough anyway. So I notice that this numerator and this denominator are exactly the same except for a switch of signs, so therefore I can cancel them as long as I leave a negative 1. So I'll have negative 1 over this denominator of 1.05. If I shift the decimal 2 places above and below, I'll have negative 100 on 105, which you can of course reduce by 5. So you'll have negative 20 21sts. Okay, so there's our answer for what? For this first slope, this secant line here, this exaggerated secant line here, right? Its slope between Q and P as it stands at the moment is negative 20 21sts, whatever that decimal happens to be. I don't know. Let me think for 1 second. Let's see here, maybe it's something like negative 9, what we got here? Maybe, let's see, negative 0.952, that's good enough. All right, that should be good enough. All right, so now let's go ahead and take care of negative 1.001 to continue this process.